This is 2.2, 2.3. Notes. Given this function right here, let's talk about where it's increasing and decreasing, and then I want to talk about local max and min. This graph does have arrows on the end. Increasing goes from negative infinity to a. And since a is connected to this next section, we're going to parentheses and union, so we're increasing right here. Keep going, and then it looks like it increases in this section right here. So that is a parenthesis B to C. And this looks like a horizontal section right there. So let's now decrease. So since this was increasing, this looks like this section is going to be decreasing. So I'm going to say A to B. And again, since A is in both sections, I'm going to parenthesis. Union, and again, this was horizontal, so I'm not doing anything there. And I'm going to decrease from D to infinity. Okay, when you have a function like this that you don't know what it's doing, go ahead and use your calculator. If you would like to plug this function into your calculator, go ahead and do so. This would be x raised to the 2/3. See what this function looks like if you're unsure. And I got that it is increasing from 0 to infinity and then decreasing from negative infinity to 0. Again, no brackets, only parentheses. Okay, now I'd like to go back and talk about local extrema, your max and your min. And there are different types of max and mins. You can find maxes and mins on your calculator, but let's just look at, since we don't know this function, your A on this one, your C and your D would be considered maxes. And in this case, I'm going to call them local maxes. Because you have more than one, you would call them a local max. You can also have a local min if there is more than one. This B down here is a minimum. I'm going to call this an absolute minimum. And I'm calling it the absolute minimum because it's the only one on this graph. Okay, your slope, it is your rate of change, or delta y over delta x, that means your change. Or you can also do y2 minus y1 over x2 minus x1. Same thing. Again, you don't have to do 2 minus 1. You can do 1 minus 2 here. It doesn't matter. Okay, when we're talking about the average rate of change, we're talking about the slope of a secant line. You may not know anything about a secant line. We have been talking about tangent lines. I want to show you the difference here. First of all, I want to show you what it looks like. When you see a secant line, you're going to have a secant line with a curved line. So here's my curve, my bad curved line, and I'm going to give you 2 points. So here's 2 points. A secant line connects 2 points on a curved line. So this would be a secant line right here. So remember, a tangent line only hits 1 point on a curved line, so it would be right here. So if you have your secant line and you want to find the average rate of change, it looks very similar to slope. That's why I gave you this formula here. It's going to look like this. It's going to be the f of your second x value and your f of your first x value over x2 minus x1. Your change in x is still on the bottom. When I say f of x2, that means that you're finding your y value from your function. So if you look over here at my picture, my bad picture over here, this is like saying this is my x1 and this is my x2. This is my function right here. I just picked these randomly. If I were to pick points that were closer together, the closer together that you point your x values that you pick, they would turn into a tangent line. If I give you this function, x minus 3 raised to the second power, find the average rate of change. And I gave you over the interval. Okay, so this would be like your x1 and your x2. So I'm going to write the formula. So remember, your top one is like your change in your y's. So this would be before, sorry, that's your x2 minus your f of 1 over 4 minus 1. Now remember, in order to get f of 4, I'm basically plugging in a 4 for this value and I'm testing it out to see what I would get. Is a 1 minus 4 over a value of 3 which is -3 over 3, and that's -1. My average rate of change, or remember, average rate of change is the same thing as saying slope of my secant line. Let me draw a picture and kind of give you an idea of what it looks like. This up here is going to be a parabola, so I'm going to plot. This is kind of what this parabola looks like. Okay, and then if I were to plot this secant line, I know if I plugged in a 1 value, I got, or if I plugged in a 4, I got 1. If I plugged in a 1, I got 4. Okay, here is my secant line according to this problem. If I were to find the slope of this, I should get -1. Okay, so I'm going to go 1, 2, 3, 1, 2, 3. Okay, so rise over run, which is a slope of -1. If a falling object's distance from the ground is given by this function, find the average of speed between 1 and 5 seconds. So average speed, again, I'm going to use my function, d of 5 minus d of 1 over 5 minus 1. Remember, plug in your 5 into your function. That gives me 400. You can use your calculator for that. Minus 16 over 4. And that's going to give me 96. Let's do feet per second. Okay, now let's continue and see what happens when we just use an A and A plus H. So we've got D, and we're going to plug in an A plus H, sorry, minus a D for A. And we've got A plus H minus A. So if you plug this in, that gives you a 16 A plus H quantity squared minus, now plug it into 16 A squared over A plus H minus A. Okay, I'm not going to keep writing this each time because my A's cancel, so I'm just going to leave an H on the bottom. Okay, hopefully you've seen this before. It looks kind of familiar. The first thing you need to do is to double distribute this A plus H squared. So this is going to be a 16 times A squared plus 2AH plus H squared minus 16 A squared, and you just have it over the H now. I'm going to distribute that 16 to get 16 A squared plus 32 AH plus 16 H squared minus 16 A squared, still over 8. This last number should cancel out no matter how many numbers you have. And then my next step, I'm going to go ahead and I've got to get rid of this H on the bottom, so you're going to have to factor. You can't just cancel it out. Factor out an H of what's left. So that gives me 32A plus a 16H over H. Now you can cancel out the H on the bottom, and that's gone. Remember, you can't just cross them out. This gives me a 32A plus 16H. And again, I have feet per second. Okay, this is my secant line again. Basically, this is telling me as H gets smaller, then my A is getting closer together. So if I were getting smaller and smaller, then my H would be getting closer to 0, and this would be going away, and I would be getting a linear line, which would be my tangent line. So it'd be getting closer to 32A. Okay, now looking at graphs, these are your piecewise functions, and you have been working with those more first semester on your APs. I know you're super excited about doing those again. On a piecewise function, just to remind you, piecewise functions start with your function notation out here. You always have, I call them squiggles, your set notation right here, your function, and then it gives you your domain. Your domain is not written in interval notation. You do not end it with a set notation. It just opens it up. So when I start this, my x, this is just the parent function, so this should be easy. I just want it less than or equal to 0. So I'm going to start at 0 and go smaller. And this is close because it's equal to. So this should be your equation. My next one is still linear, and I'm going to be greater than 0. So I'm going to start at 2 and do an open circle and do a slope of 1 over 2 and increase to the right. I do have a skip here, but that's okay. I'm going to go ahead and do my, so domain going from left to right. So left would be negative infinity. If you're going from your left to right, you do have a skip here, but because you have an open and a closed circle, those will kind of take care of each other. Your closed circle will cover up your open, and you will continue all the way to your right. On your range, you've got negative infinity, 2, how about 0? That is closed. You're going to union, skip this area, pick back up at 2, and then go to infinity. And it says, is the function continuous? This right here answers it, and it is yes. If this question says continuous over range, the answer would be no. And it's no because it skips right here. There's a hole going up. So x-intercept is going to be 0, 0. And it looks like your y-intercept is also 0, 0. Okay, on number 2, it doesn't matter which one you start with. I'm going to start with my linear one. So x plus 2. But I just want it less than or equal to negative 1. So be careful there. If you have trouble with these, you can start with x plus 2. It starts at x plus 2. And it basically looks like this equation, right? Okay, but I only want less than negative 1. So I could erase what I don't need here, and I just need negative 1. So I could just go in this direction like this. And then this is just a parent function for a parabola. If you notice, I did go ahead and color this in because it was already shaded in from my equation or my line. So it's still going to be colored in. Domain looks like it's continuous. And then range looks also continuous. So is the function continuous over the domain? Yes, because there's no skips. It would also be continuous over the range. Okay, x-intercepts. It looks like there's one at negative 2, 0 and 0, 0. And my y-intercepts are 0, 0. Okay, this one's not graphed, but just to show you how easy this, it says, what is g of 2? So I'm just going to look right here. Where would 2 fall? It's going to fall right here on this one. So I'm going to plug in 2 to this equation. So 2 plus 5 is 7. Negative 3 falls in this and 0. So negative 3 quantity squared is 9. 0 falls in the second one because it's equivalent. So 0 plus 5 is 5.